So we should have picked up the assignment from yesterday. Okay. I'll read the pictures out just in case somebody didn't pick one up. We're gonna learn how to do the top part too. Okay, it's too much stuff for me to do both the activity series charts. I have somebody that wants for that. And the solubility chart all in one lesson. It's just too much. And I know there was a question. Well, he's not in here right now. There was a question about yesterday's with the bottom part. The bottom part, you were looking to see if the reaction was going to take place, which both of them should have taken place. I haven't made a key yet for this one. I guess I can do that while I'm working on this. And basically, you were trying to figure out if the thing by itself was essentially a bullet. If it's stronger, it kicks out the weaker one and it takes its partner, steals it from the main. So for this opener, yesterday's charts, let me know this with you, says which nonmetal would be able to replace chlorine in a single replacement reaction. So that's this little one. So chlorine is the second one down. So what's the only nonmetal on that list that could kick out chlorine? Fluorine, because fluorine's at the top and it's stronger. Chlorine. And then it beats up chlorine and it steals the chlorine. So once again, this chart, if it's further up, well, both charts, if it's further up, it's stronger, and it can kick out anything that's below it. It can't kick out anything above it, but it can kick out everything below. So in this case, if you're looking at that little chart, chlorine could not replace bromine or iodine. It would throw itself, no, wait. Yeah, it would throw itself. No, I'm saying this the wrong way. Fluorine, if it was by itself, would kick out chlorine. Chlorine, if it was by itself, could not kick out fluorine. It literally would be like throwing itself at a wall and just keep bouncing off. Like it's not going to do anything. No matter if you put more in there. The only thing we could try to do is introduce what's called a catalyst. I haven't even remotely talked about catalysts yet. Like it jump starts the reaction, makes it go. Let's see, which three elements will be able to replace calcium? So now over here we have calcium. There are three elements on that list that would be able to replace calcium. What are they? Lithium, potassium, and barium. If those were by themselves, they would be able to kick out calcium. But everything that's below it, they wouldn't. So that would be sodium, magnesium, aluminum, all the way down to gold. I'm not going to list all. There's like 20 of them. I'm not going to list all of them. You're good on. Sorry, I had an ARD. There, that's what I'm looking for right there. I had an ARD today and it took up a lot of my prep period, so I'm still running around in circles. So the first one, the only thing that would be able to kick out chlorine is fluorine. The second one would be the three elements above it, which are lithium, potassium, and barium. Now, your test, so I talked to both you guys and to my 8th period, and everybody seems to think that you need 2 days of review for the test that's on Tuesday. So instead of doing that lab, which really doesn't have a lot of practice in it, I've already printed out the review. I've already taken a look at the test. Most of the test is actually fairly simple. It's vocabulary. But if you don't know how to balance or do the formulas, that's where you're going to struggle. So that's what we're going to focus on more between tomorrow and Monday. What I may do actually is the harder stuff tomorrow and then do a Kahoot game for the vocabulary. Because with you guys, I haven't done that. With my Earth Space, if they get first, second, or third place, it translates into extra credit test points. I haven't done that with you guys because this is more of an applied class, and my Earth Space is more of a vocabulary class. Just, I haven't gotten into hard mathematics there. Fluorine is the only one that will replace the chlorine. So that's the first one's answer. The second ones are, and I have to keep looking. So I'm not going to make you memorize this chart. Those charts up. They're either going to be printed out because I can't add them onto the test, or I put a link in with the test thing, or you can click on it. And I'm also not going to make you memorize this big honking thing. This is too much to ask you to memorize. It's not fair. It's called reference material. So I need to just make sure that you know how to read it instead. It's not hard. Just like this one. Once I showed you how to read this, and then I explained why we were doing it in the first place, most people, why am I hearing this? Put the phone away, turn it off. This is not hard to use. You just have to be taught how to do it. So we get to learn how to read this big, ugly chart. It's called a solubility chart. What does it mean if something is soluble? It will dissolve. So if it's insoluble, what does that mean? It does not dissolve. Now there's a couple of words that I need to teach you, and I'm going to show you how we do the abbreviation. Yesterday's were all single replacement reactions. Today's are all double replacement reactions, or displacement, depending on how your professor or teacher, who TA, whoever they learn. First thing that we need to do is to identify our charges. Okay, so you have on your periodic table, the regular group 1 and 2 could be Roman numerals if it's written out in words. You may need to look at your polyatomic ion chart, but you need to know your charges. When you move them from the reactant side to the product side, you don't move over a subscript unless it's a polyatomic subscript, like phosphate is PO4. That 4 has to go with PO4. Y'all, it's capital P, capital O4. If you do capital P, lowercase o4, it's talking about polonium, radioactive element. So make sure you're paying attention to the capitalization. Oh, let me go back. Thought there was one more on there. I was mistaken. It would help if I got my cheat sheet out. We need to attendance to you guys. Too many papers out. Anybody still need this? Nope, you're not absent. We go forward. More learning how to use that chart than anything else. The notes themselves are short, like yesterday's words. How do you use it in reinforcing balancing equations? Because I know that that's where people are still struggling. 3 things make a double replacement reaction go. There's 3 driving forces, three catalysts almost, if you will. The first thing is if it forms what is called a precipitate, which we abbreviate lowercase p, p, t. So if you see that, that's shorthand for precipitate. If it precipitates outside, it's raining or snowing or sleeting, right? So precipitation is? In chemistry, it's when you take 2 liquids and you combine them together, and when they react, a solid forms. It literally falls out of the solution, which is precipitation. Like it rains, it falls out of the sky. It's not a, well, I know rain's a liquid, but sleet, hail, snow, that's a solid form. You have to be able to look at that chart to figure out if it's insoluble, which is the hard stuff. If it's soluble, then it's going to stay a liquid. Unfortunately, there's a whole bunch of except for this. So you have to pay attention to everything in the compound. If it makes a gas, the reaction is going to go. Or if it makes a molecular compound, or covalent, which means it's all nonmetals, the reaction is going to go. So gases would be like carbon dioxide gas, hydrogen gas, carbon monoxide gas, all different types of gases. To see if you have a solid form, you're going to take a look at this chart. You need to take a look at the negative ion, which is the thing on the right. Okay? Could be a polyatomic ion, it could be an elemental ion, or you're paying attention to the ammonia ion, which is the only positive one on that chart. And then you're going to, whatever those are, you're going to compare it to this chart, and you're going to figure out if it's soluble or if it's insoluble. Okay, the top chart is telling you if it is a soluble thing, and the bottom one is telling you if it is an insoluble thing. You have to pay attention to which chart you are looking at. Okay, we're going to take a look at a whole bunch of these. We are looking at the negative ion. What is the negative ion in sodium chloride? The chlorine is. So I now look to see where chlorine is on this list. I'm going to wait. You got to flip your notes over. Find the chlorine. Cl minus, which means -1. Is it in the soluble group or the insoluble group? In the soluble group. So it says for chlorine that it is soluble unless it has silver, lead, and mercury with it. But Pb is lead and Hg is mercury. So as long as it doesn't have one of those, then it will be soluble. Was sodium listed? No. So this is a soluble compound. So is it going to form a solid if it's soluble? No. It has to be insoluble in order to form a precipitate or, oh, that should be up a little bit, sorry. But no. That means that this reaction is not going to go. Okay. Sodium or silver chloride, still silver, still chlorine, but was silver listed as an exception. Okay, so that means that this is insoluble. So is it going to form a solid precipitate? Yes. That is how you use these charts. It's, first of all, pay attention to which one you're dealing with. As long as it doesn't have that exception, it's going to do what that chart says. If it has an exception, then it does opposite of what its title says. This one has two things. It has ammonia and it has a phosphate ion. So let's see. Phosphate is in the bottom one and ammonia is in the top one. So let's start with the ammonia, NH4. Does it have any exceptions at all? No. Okay, so that means at least the ammonia is soluble. And now we need to check the phosphate. So down on the bottom, now remember, the bottom chart is insoluble, which means that as long as it doesn't have an exception, it's insoluble. If it has the exception, it's soluble. Is ammonia the exception for phosphate? So that means it's not insoluble, it is soluble. So as long as both of these are going to dissolve in water, then it will be soluble. If one of these two was not, then it would be insoluble. So it will not form a solid precipitate. Is there anybody that's not seeing where I'm getting these, doesn't understand like it's kicked in the other category? All right. Sulfate. Let's find sulfate. It is in the top group. It's in the soluble group. The exceptions are strontium, barium. So barium is an exception. Lead and mercury. So if barium is an exception and it's in the soluble group, then it's going to change it from soluble to insoluble. And is it going to have a solid precipitate out? Yes. This was on yesterday's assignment. The bottom part. That's here it is. This was using the activity thing, and you were just figuring out who was the stronger compound. Well, this is our stronger element. This is the same thing on the top, but you're figuring out, is it going to be soluble or insoluble? And I just looked at, does it make the reaction go or not? Nitrate. I found my paper. Nitrate is in the top part. It has no exceptions whatsoever, so it will be a soluble compound, and it will not form a solid precipitate. The reason why we're figuring out if this is formed or not is because if a precipitate forms, the reaction will go. So yesterday's was well, depending on what the ion was, if that element was stronger than the one in the compound, then the reaction went. With yesterday's, if it was weaker than the one in the compound, then the reaction did not occur. With this one, if a precipitate does form, it's going to force the reaction to occur. If there is no solid precipitate, then the reaction will most likely not occur unless you have a gas produced or you have a molecular compound produced. Okay. We're going to apply it now. This is the part that takes longer. And we're going to go back over balancing yet again. So with this one, we are taking a look at our compounds. Nitrate, NO3 is in the top part. There are no exceptions. That compound is a soluble compound. We better hope that the other thing makes it precipitate. Chlorine, since first chlorine is in the soluble group, but silver is an exception. So is that last one going to be a precipitate? If this is soluble, but this is an exception, what does it do to the compound? It makes it insoluble, which is a precipitate. That's what PPT is short for. You have to have an insoluble compound, and honestly, all the ones that we would ask you to do is they shouldn't have any exceptions, like the gas being produced or the molecular compound. Now we get to balance it. So here's the part that a lot of us still need help with. On the left, how many aluminums do you have? 1. On the right, how many aluminums do you have? 1. This should be animated correctly. Thank goodness. Okay, next, on the left, how many chlorines do you have? 3. How many are on the right? 1. Is there still anybody that has a question how I'm getting these numbers? Okay, how many silvers are on the left? And how many silvers are on the right? Okay. And then the last one is the one that I'm noticing that people are having problems with. Nitrate is on both sides. Nitrate is NO3 and it carries a -1 charge. You are not changing that number. If there's more than 1, then we put it in parentheses and how many is outside. So with that said, they can't see me pointing at the board online. How many nitrates is in silver nitrate? 1. How many nitrates is in aluminum nitrate? 3. I'm seeing people, like on the left-hand side, what I'm seeing people do wrong is I'm seeing people do NO, and then they would tell me that there's 3 of them. No. Nitrate is NO3. It carries a -1 charge. You only break things apart if it's on one side and not the other. So now let's start at the top. Is aluminum okay?
Yeah.
Is chlorine okay?
No.
No, and let's hope that I animated this. So I should do times what over here? Yay, I did it right. Where does this multiplication 3 go? It goes on the right-hand side of the equation in front of the compound that has chlorine, which is right here. And this is the next thing that I see people do wrong. And like I said, it's not that the multiplication is hard. It's being patient and taking your time and not trying to do too many things at once. So before I can do anything else, what does this 3 do to the silver? That's it times 3. Okay, so I have to double check. Is aluminum still okay?
Yes.
Is chlorine okay?
Yes.
Is silver okay? It used to be,
No.
but it's not anymore. So what do you do to the reactant side, the left-hand side, in order to get it to have the same value? But where does it go? Does it go here? Or does it go here? Where's the silver? That's right there. So I'm going to go ahead and put that there. And I'm going to multiply it to the nitrate also, or distribute it, whatever word you want to use there. How many nitrates do you now have on the left? Multiply, don't add. You had 1. 1 times 3 is 3. And I have to double check again. Do you see anything else that needs to be fixed? This one? I did. Times the nitrate, which actually fixed it. I've seen that some people, okay, I think, Jimmy, you were one that was, I'm not trying to pick on you, but I think what you were doing is you were like putting numbers up here and you were like double multiplying some things. And I know with some of you, with the water, you were trying to add the 2 + 1 on the combustion and trying to balance it that way, and it doesn't work. It doesn't work like that. If everything is okay, what number should I drop in the 2 blanks? Ones. Okay, so since I've not actually had a chance to take a look at the test, it's Tuesday. I haven't analyzed the entire thing. I just glanced at it. There are questions that, what coefficients would fix this? And so for this one, you would look for the answer that says 1, 3, 1, 3. Before I move on to the next one, okay, is there any question at all where I got these numbers from in black, or why I distributed to the other things in the compound? Okay. Okay, next one. This is the harder stuff that we could ask you to do. We have to make the compounds first. Okay, that's the part that if you don't get that right, nothing else is right. A precipitate is going to be formed, the reaction occurs. Okay, whatever. That's fluff in the question. Aqueous just means it's liquid. That's fluff in the question. The first thing that we see is potassium chromate is mixed with, which is the plus, an aqueous solution of lead nitrate. Okay? Aqueous just means it's in a liquid state. Doesn't mean to do anything special. It gives me both reactants. We have to make them. Let's do potassium first. What letter's potassium? Because it's not P. K. And what is the charge of the things in group 1? +1. I should have relinked the polyatomic ion chart up to the top. Okay, you need to find chromate. Chromate does have chromium in it. Now don't find dichromate, find chromate. It's over here. I relinked this into the module at the top. This should be at the very top. Chromate is Cr O4, and it carries a -2 charge. I'm not going to build it yet. I'm going to put all my stuff down first. Then the other one is lead 2 nitrate. Lead is Pb. According to that Roman numeral, what is the lead's charge? 2. Oh, it should be scooched over a little bit. Oh, well. And then nitrate is also on this thing. Nitrate's over here. Make sure you're doing nitrate and not nitrite. Nitrate is NO3. It carries a -1 charge. And so, like I said, this is reinforcing all of the stuff that we've been doing for about 10 weeks now. These charges, this one's charge, it was a group 1, it's directly above group 1. This guy is a transition metal. Well, he's a not 1 or 2A element. So I had to know that 2II was 2. And then I got these guys from my polyatomic ion charts. So like I said, I will either provide some paper copies or maybe give you a digital link. I will find a way to figure out how to do it. I might make this today. Now, they're going to flip-flop with each other. Instead of the potassium being with the chromate, what's the potassium going to be with on the other side? It's going to be with the nitrate. And so who is the lead going to be with? It's going to be with the chromate. I did the lead one first. So I have all the stuff I need over here. I don't have to look it up anymore. The lead is going to combine with the chromate, okay? And make sure you're doing the positive one first. The potassium is going to group up with the nitrate. Now we have to make every single stinking compound. These don't add to 0. What do you do with the numbers? What do you do with these? Switch them. So I'm going to need 2 of every one of these for every one of the chromates, but we don't write a 1 as a subscript. And you only have to use parentheses if there's more than one polyatomic. So the formula for the potassium chromate is K2CrO4. Now I have to build the lead 2 nitrate. Remember, lead 2 does not mean it has 2 of it in the compound. It means it's +2. The nitrate's -1. What do you do with those numbers since they don't add to 0? Switch them. You need 1 lead. I must put nitrate in parentheses first, and then the 2 goes outside. If you do not use parentheses and you write NO32, you're telling me 32 oxygens. Parentheses tells you have 2 of what is inside. Let me take official attendance. Let's see, Brayden. Caitlin is not here. I'll see if she's online. Double check that. Skipper's online, Sahara's online, Tiffany Lucas, Declan's online, Tatiana. I didn't see Alexis yet, but I bet she's online. Jimmy, Sebastian, Matthew. If you're online and I'm calling you, I haven't checked again. Bailey's not here. Veronica, I think that's online. Not yet. Valerie's here. Luke is here. Robert's here. Mia's here. Reagan's online. Yes. Aiden, I think, is online. George is here. Logan's here. And Jeremiah's here. Okay. So on the right-hand side, do these 2 values already add up to 0? The lead and the chromate, do they already cancel each other out to 0? Yes. So we don't write any extra subscripts. You don't need any parentheses. And then do these also add up to 0? Yeah, so it's KNO3. Now I know it says the precipitate forms, but I'm going to reinforce this chart since that's what today's lesson is on. We look up the chromate. Chromate is down here on the bottom part, is an insoluble part. It says it is insoluble unless there's ammonia in a group 1 metal. Okay, is lead a group 1 metal? Because that lead is not ammonium ion. So is lead all the way on the left-hand side in group 1? No. So there's no exceptions. So this is my yellow precipitate. The nitrate, it's completely soluble, but you only need 1 precipitate to force the reaction to happen. And now we're going to balance it on the next slide because I can't fit everything on one because the pipe would be this big. Before I go to the balancing, are there any questions why I found out that we had a true precipitate? All right, I'm gonna redo it. And I went ahead and did all the stuff underneath. So while I check my attendance really quick, I'll let you guys fill that out so you're not trying to write and listen at the same time. Check online. I am missing. Oh yeah, I do see Alexis now. I got you. I'm looking for Caitlin and Matthew. Oh, is that just what? Okay, what chart? Aiden, on today's notes, the second page, did you see where it is? Here, I can show you. I can turn on my thing and show you. I normally don't keep my camera going because it can't see anything. It's at too much of an angle. So I turn this on. So on the notes, this, if you flip it around, that's the chart. And what was it? The lead chromate. So it's hard for me to. I can't do this backwards. Here's the. Here it is. Here's the chromate right here. It's in an insoluble category, and when I go over to the side, over here, this is so weird because it's backwards to me. It's like, and I know it's not to you. It says that the as long as it doesn't have ammonia or a group 1 element, and you can't see anything. Oh, no, you should be able to. Here, let me do it this way. It's because you're looking at the pin screen. You're not looking, because I've made my thing 32B. Come on, open up. I'm going to change all this, stop presenting. I'm going to present my entire screen. We're going to do it this way instead. And I'm going to turn that off so that you guys aren't trying to look at more than one thing. Okay, so on here. No, where to go? Okay, so on this, here's the chromate. Okay, it says it's insoluble, which means it's going to make a precipitate as long as it doesn't have ammonia or that an alkali metal is a group 1. Group 2 is an alkaline earth metal. So then you have to look at lead and make sure, because that's not lead, that's ammonia. But lead is not in group 1, it's way over in group 4. So that means that it stays insoluble. And if I go back to this, where they are, that this is my precipitate. This one is insoluble. If you have nitrate in the compound, it's going to be soluble. So as long as you have one, then it's going to go through the reaction. You guys should be seeing, let me make sure people, presentation. Okay, it should be stop sharing, present, tab, and put it back on the right thing for you guys. I'm sorry, this takes a little bit for me to go back and forth. Okay, now we're going to balance it. And like I said, I'm not going to make you guys memorize these charts. It's just not cool. I'm hoping that the other teachers are like that too. No, if I have to resort to the stupid chart, then I shouldn't expect you to memorize the entire thing. It's just not right. So on this guy, we have 2 potassiums on the left. We've got 1 potassium on the right. We have 1 chromate ion on the left. We also have 1 chromate ion on the right. We have 1 lead on the left. We have 1 lead on the right. So everything is great until the fact that we see we have 2 nitrates on the left and we only have 1 nitrate on the right. So, oh, actually the potassium, let's start with the potassium because that's the one on the top. How are you going to make the Ks have the same value? Times 2. Okay, and this multiplication 2, here's the compound that has it. If you're not putting your line directly underneath the arrow, I would start doing that. Because otherwise, if you like draw it over here, you may think that this compound's over here on the side. Now, before you move on, what did it do to the nitrate? Times 2. Is there anything else that has to be done? Technically, there's 3 more things that need to be done. What else do you have to do to be able to have the right coefficient ratio? What goes here in those 3 holes? 1s. Just because there's more things up there doesn't mean it's necessarily harder. The hard part about this was building all the compounds out of the sentence. Okay, is there anybody that, let me freeze this. Is there anybody that needed another copy of this thing? The assignment from yesterday. Y'all still have it. You turn away. So what we're doing, and I will walk through one with you to make sure that you just, it's not this part. Okay, what you're doing on the assignment is, it's the same paper from yesterday. So let me look here. Oh, if I was double echoing, I'm so sorry. Alexis, Aiden. Okay. I'm going to be writing on the board for those of you that are remote, but I'm literally talking through it. If we look at the very top one, it says NaI. We have the compound. Now this is using today's chart, not yesterday's chart. It wants to know if it's soluble or insoluble. And then it wants to know, does it make a precipitate? Okay, so the first one is sodium iodide. Take a look at your chart and find the iodine ion. Which group is it in first? Is it in the soluble or the insoluble group? Iodine. Which group is it in? Soluble group. Does it have any exceptions? Yeah. Okay, so the other thing is sodium. So it says except silver, lead, and mercury. Was sodium just listed? No. So does it stay soluble or does it change to insoluble? What? It's soluble. So if it's in that group, it stays that way as long as it doesn't have the exception. Sodium is not an exception, so that means for the NaI, which is already filled in for you, this is soluble. So does it make a precipitate?
No.
No. Oh, that's what you're doing for the top part. It's giving you lots of practice to figure out, is the reaction going to go? In this case, it wouldn't, as long as the other thing was also soluble. And now, there was a question over here from the one from yesterday. Put this on. Did you figure out what from yesterday? Did you figure out what you were doing, or did you still have a question on it? You're talking about the very bottom two on this paper. Let me see. Because we have 10 minutes in here for you to do this.
I don't think
Okay, so you need this one. So we have to find aluminum and iron. Here's aluminum. Here's iron. Who's stronger? Aluminum. So is he going to kick iron out? Okay, so that means that the Fe is going to be by itself, and the Al is going to group up with the oxygen. Yes. So you can go ahead and write what you just said. Now that iron is okay because it's not one of the 7 elements. These, you need your charges. So aluminum is always +3, oxygen is always -2. So you need to crisscross them. So how many aluminums do you need? This tells you how many of that one you need. This tells you how many of the other one. How many aluminums, how many oxygens. Then you just have to balance it. Yeah. If it's +3, -3, +2, -2, or +1, -1, it varies against that. You don't put. But if it's like +1 and -3, then it's one of these and it's 3 of those. Yeah. The only trick is if like one is +4 and the other one's -2, then it's not 4 and 2, it's really 2 and 1 because you have to simplify. Okay, was there another question? Am I doing this right either from yesterday's stuff or from today's stuff? Let me see if I have stuff to pass back to you. If you did not turn in the second balancing paper, the more balancing equations, that is due. I have one from Tiffany, Sahara, and Jimmy right here. This is, Reagan is online, so I can't hand that to her through the computer. I am checking your stuff online. If I see stuff that you did wrong, I try to put the X where the error was. It's a little hard doing it digitally. You're done with this one. And if you finish with today's, awesome. Instead of doing that lab tomorrow, we are going to be starting a review because I know some of you need a lot more practice. Let me double check my online students. Oh, here, let me stop my recording. Should have done that a while ago.